The rules we learn on how to compute the first order derivative can also be applied when working with multivariate functions. We just need to pay attention with respect to which variable we are taking the derivative on and which variables will remain constant. This notion applies to the 5 rules of derivation. To illustrate how this works, let's see the following examples. In this first one, we want to take the partial derivative of this function with respect to x and then with respect to y. Notice that this is a product rule. To take the derivative of this function, notice that with respect to x, x appears in both factors. Therefore, we need to use the product rule. The derivative of z with respect to x, considering that this is a product rule, remember that we copy both factors twice. However, in the first part, we take the derivative of the first factor, and in the second part, we take the derivative of the second factor. But notice and remember that we are taking the derivative with respect to x. So taking the derivative with respect to x for the first term, first we need to look at which terms actually contain x. And here is only for x. The derivative of 4x with respect to x is simply 4. Plus, because 5y squared does not contain x, the derivative is simply 0. Because this means that this part is a constant. Times the second term. Plus the first term times the derivative of the second factor with respect to x. Here only 8x squared contains x. And the derivative with respect to x is simply 16x plus 0 because 5y doesn't contain x. Cx is equals to 4 times 8x squared plus 5y plus 4x plus 5y squared times 16x. The x is equals to 32x squared plus 20y plus 64x squared plus 80xy squared. The x is equals to 96x squared plus 80xy squared plus 20y. Now let's take the derivative of z with respect to y. Again, notice that y appears in both factors. Therefore, we need to use the product rule. So we repeat both factors twice. And we take the derivative of the first term between these two factors plus, and then from the second part, we take the derivative of the second factor. Now, because this is with respect to y, both derivatives has to be taken with respect to y. So here the only part that contains y is this part. So this is derivative of 4x with respect to y is 0 plus derivative of 5y squared with respect to y is 10y. Then on the other side, the only part that has y is 5y. So this is 0 plus the derivative of 5y with respect to y is simply 5. So zy is equals to 10y times 8x squared plus 5y plus 4x plus 5y squared times 5. So this is equals to 80x squared y plus 50y squared plus 20x plus 25y squared. Let's simplify these two terms and we will get 75y squared plus 80x squared y plus 20x. So that is the derivative of z with respect to y. Now let's solve the case of a division. Here we have 4x plus 5y divided by 2x minus y. Because x appears in the numerator and denominator, we need to use the quotient rule. And again, for the case of the quotient rule, we copy both terms as a multiplication twice. And we divide everything by the denominator square. And remember, in the quotient rule, we do something similar as we did in the product rule. In the first term, we take the derivative in the first factor. And in the second term, we take the derivative to the second factor. Because this is a quotient rule or a division, the sign in the middle is a negative sign. Both factors which are in red are the factors that we will take derivative, and remember, with respect to x. In this factor, only for x contain x. So the derivative of this factor with respect to x is simply 4. In the second factor, only 2x contained x. So the derivative of 2x with respect to x is simply 2. And then everything is divided by 2x minus y squared. So now we just need to simplify. This is 8x minus 4y minus 8x minus 10y. We can simplify 8x minus 8x, which means that the derivative of z with respect to x is minus 14y divided by 2x minus y squared. Because y also appears in the numerator and the denominator, when we want to take the derivative of z with respect to y, we also will apply the quotient rule. Again, this is the derivative of the first term times the second minus the first term times the derivative of the second, and everything divided by the second term squared. Now remember, we are taking the derivative with respect to y. In the first term, the derivative of 4x with respect to y is 0, because the only part that contains y is 5y. The derivative of 5y with respect to y is simply 5. The derivative of 2x with respect to y is 0, and the derivative of minus y with respect to y is minus 1. Now we just need to simplify a little bit. So this is 10x minus 5y plus 4x plus 5y. Here we can cancel minus 5y plus 5y. So the derivative of z with respect to y is 14x divided by 2x minus y squared.